All right, hello not algebra 2. Hello geometry honors. Today we're going to look at lesson 11.2, areas of trapezoids, rhombuses, and kites. So previously we looked at squares, rectangles, parallelograms, and triangles. And most of those formulas were base times height or some manipulation of base times height. Well, today we're going to look at the trapezoid, rhombus, and kite. Turns out two of these formulas are exactly the same. One is different. The one that's different is another adaptation of base times height. So without further ado, let's go ahead and jump in here. It turns out that the area of a trapezoid is 1/2 the product of the height and the sum of the lengths of the bases. All right, so draw yourself a picture of a trapezoid, will you? Trapezoid has exactly one pair of opposite sides parallel. And they're saying you're going to need a height. Remember, a height always makes a right angle with the base. And they're saying that, you're going to have the sum of the bases. So remember, with the trapezoid, your bases are not the same measurement. So what they do to handle that is they say, well, you've got one base sub 1 here. You've got another base up here. We'll call that base sub 2. And the formula is area equals 1/2 times h times the sum of B1 plus B2. Well, with formulas, I often find like they kind of seem overly complicated. Let's just think about this for a second. The reason you got this 1/2 is because what you're doing is you're taking the average measure of the bases. You're getting the average measure of the bases and then multiplying by the height. So this is actually base times height. It's just that your bases aren't the same, so you got to get the average of them first. And by the way, the average of the bases is also called your midsegment. So it's basically the midsegment times height is what's going on here. For a rhombus, the area of a rhombus is 1/2 the product of the lengths of its diagonals. So this is getting interesting here, okay? So let's draw ourselves a rhombus. Remember, rhombus is quadrilateral. All the sides are the same measure. But we're talking about the diagonals here. And do you remember what we know about the diagonals? Because they're a parallelogram, the diagonals do they do bisect each other. It doesn't mean they're all the same measure, but they do bisect each other, split each other in half. But also they're perpendicular, which is kind of cool. So it says it's 1/2. Let me write this out. It's 1/2 the product of its diagonals. Well, the diagonals are not necessarily going to be the same measure. More often they are not. So what you got is you got diagonal 1 and diagonal 2. And so what you'll often see is on the outside, they'll do a little bracket and say, all right, so this is the total length of one diagonal. This is the total length of our other diagonal. They'll mark it like that. Or they might give you a measure here and you have to realize you got to double it, right? Or a measure here, you got to double it if it's on a rhombus. Hey, keep in mind, a rhombus is also a special type of parallelogram. So there's actually a couple formulas you can use. You can either use this if you're given diagonal information, 1/2 diagonal 1 times diagonal 2, Or if you're given a base and a height, you can totally do base times height because it's a special type of parallelogram. Additionally, a square is a special type of rhombus. So you can do side squared to get the area of a square, or if you're given diagonals, you can do 1/2 diagonal times diagonal to get the area of a square, which is pretty cool. And I swear I've seen it on an ACT question where it made the problem way easier if you knew that you could get the area of a square by using 1/2 D1 times D2. All right, so the area of the kite is same as rhombus. And basically, I think it comes from the fact that, let's draw a kite real quick. It comes from the fact that when you draw the diagonals in, they're also perpendicular. And so basically you've got a bunch of right triangles. You got a bunch of right triangles. And if you find the area of each of those right triangles, it'll simplify down and add them all up. It'll simplify down to 1/2 diameter 1 times diameter 2 for both of these. Now, keep in mind on a kite, if you know, so notice this diagonal is not bisected. This one is though. So kites they have a line of symmetry across one diagonal, so you know that some measures are the same, but you don't have a line of symmetry going this way, so these aren't the same measure. So you just gotta be cautious. Now, what can happen here is they'll give you a little bit of information, and guess what? You'll have to use Pythagorean theorem, or you'll have to use special right triangles, or you could even use trig on some of these depending on what information is given. If they give you an additional acute angle somewhere, you could use trig to figure out missing sides. So please be on your toes. Anything that we've learned as far as solving right triangles is going to be in play here, and you might get to use it. So again, you got the setup where you got a diagonal. They'll often mark it on the outside like this, and another diagonal. Okay, so same formula. Okay, let's try some of this out. Let's see, front of a chest is a trapezoid as shown. Find the area of the front of the chest. So I would encourage you to write out these formulas until you've got them memorized. It said it's a trapezoid, so I'm going to write this out. And do I have the height? I think they intend for that to be the height. Do I have both my bases? So I'm off to the races. I know everything I need to know here. I'm going to try to keep my units in there, even though it's going to get a little cramped. And you can put this into your calculator directly. You could try to do it by hand. Oh, this is 30 inches. Half of 20 is 10. 10 times 30. Looks like we're at 300. And what's our units going to be here? Well, you're going to end up with inch. Multiplying together makes inch squared. Oh, sorry, I was got a little off the page there. All right, example 2. We've got a rhombus. Rhombus ABCD is part of a quilt. The area of the find the area of the rhombus. So notice what they're giving you there, what they're pointing at. 3 is not the entire diagonal, but because it's a rhombus, the diagonals bisect each other, and if that's 3, so is that. If this is 6, so is that. And now I think we've got everything we need to know. So for the area of a rhombus, you go 1/2 one of the diagonals, which one of these diagonals, 3 and 3, would make 6 inches, and times the other diagonal. If it's 6 inches together, we've got 12 inches right there. And beep boop 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 beep in our brains, we've got 36 inches squared. Okay, example 3. One diagonal of a kite is 1/3 as long as the other. Okay. The area of the kite is 0.24 square meters. What are the lengths of the diagonals? Okay, I like to have a picture here. I could totally work this problem without a picture, but pictures are sometimes helpful, sometimes necessary. This one, I don't think they're totally necessary. But it says, so kites look something like this. They're gonna have a right angle there. So I like to put that in because you never know if you're gonna have to do Pythagorean theorem or trigonometry, special right triangles, one of those things. But it says that, and I'm going to use the notation outside here. It says that one diagonal is 1/3 as long as the other. Well, since the way I drew it here, this diagonal is smaller, so I'm going to make this one x and this one 1/3 x. Do you remember having to do this when we were doing like, it was like segment lengths, where we'd say like one part of a segment is twice as long as the other part of the segment. And then, we would do things like that earlier in the year. All right, so now we've got representation for our diagonals. They say that our area, so remember the formula's area is 1/2 diagonal times diagonal 2, okay? But it says our area is 0.24 meters squared. And we're going to have one diagonal as x and one diagonal as 1/3 x. Well, what's going to end up happening here is we're going to get a half. We'll multiply with the third, simplify with the third to get 1/6. The x's will multiply together to get x squared. And then to solve this, I'm going to have to undo this 1/6. I'll probably multiply by 6 on both sides. 1.44, and I dropped my units there, meters squared is equal to x squared, and then square root both sides. Punch that in your calculator, see if it comes out nice. And 144, that's square root of 144 is a perfect square, so it's 12, but because it's 1.44, it's gonna be, 1.2. 1.2. And when you square root meters squared, you're left with meters. So this is one of my diagonals. My other diagonal is going to be 1/3 times that, or divide 1.2 by 3, and you're going to get 0.4 meters. And we've done it. Okay. Example 4, I would encourage you to pause the video and try this one out yourself. So go ahead and try that. All right, so now it says a logo design is drawn on a grid where each grid square is 5 inches by 5 inches. Find the area of the design. You could do this like roughly by just counting how many blocks and knowing that each block has an area of 25 inches squared. You could totally do that. On a multiple choice test, that's probably how I'd go about it, because one of the answers should be reasonable. But we actually know, because horizontal lines are parallel, that we've got a trapezoid here. So let's go ahead and use the formula for that. 1/2 the height, base 1 plus base 2. And the height here would be along, they actually got a right angle drawn there, which we know would be a right angle. But anyway, we've got 5, so we're actually going by 5s. 5, 10, 15, 20. 20 inches. One of our bases is 5, 10, 15, 20, 25 inches. And our other base is 5, 10, 15, 20, 25, 30, 35, 40 inches. And we can figure this all out. That's 10. This is 65. 65 times 10 is 650 inches squared. So hopefully you got that as well. All right, so we'll finish up these notes tomorrow. Thanks so much.